Hello, this is part 2 in the video series on solving an applied linear programming problem. So in the previous video we looked at this scenario with an iron manufacturer making 3 products, and we set up 3 variables. We're looking to maximize profit subject to these constraints. So if you want to go through on how to set up the problem, please watch the previous video and take good notes. In this video, assuming we've already kind of set up our linear programming problem. Ooh, and I just see a mistake on the previous one. This should be less than or equal to 30,000. That was the maximum number of hours. So we've got 6 constraints technically, and then maximizing profit. So what I want to do is use Excel. I'm going to use Excel's solver. So I'm going to use Excel's solver to find the maximum profit. Okay, so I'm going to go over to a blank Excel sheet, as we have right here. And I'd like to see both of these on the same window. Okay, so I'm going to first set up variables. In this problem, I have 3 variables, x1, x2, x3. And on the B column is going to be the value for those variables. I'm just going to enter 0 for right now. All right, then I need to type up or write up the objective. We want to maximize profit. The profit function, and I'm going to type that in the second column, B. So that's going to equal 10 times x1, but that is in the cell, B2, plus 25 times x2, plus 3 times x3. And click on enter. So max profit 0, because Excel has entered 0 for all those values. And now I need to enter the constraints. And I want to set this up the same way as we did before. So this is going to be value. I'm going to do equality, and then right hand side. And I'm going to just write in the first 3 constraints. I'll show you why in a second. So the value on the first constraint, start with an equal sign in Excel. I'm going to enter this right here. 3 times x1 plus 10 times x2 plus x3. Click on enter. The inequality in this case is less than or equal to, and the right hand side is 30,000. Constraint number 2 is right down here. So I'm going to type in equals 5 times x1 plus 8 times x2 plus x3. Click on enter. The inequality for that is also less than or equal to, right hand side, 40,000. And then the third constraint is going to be 0.1, excuse me, don't forget to start with an equal sign, 0.1 times x1 plus 0.6 times x2 plus 0.1 times x3. Click on enter, and the third constraint is also less than or equal to, tab over, right hand side, 120 hours. So now I've set up my system of linear equalities in Excel. So I'm going to maximize this. And on the top, from the home screen, click over to the Data tab, and then Solver. And scroll this over. I want to solve, start over. So set objective, click on the objective cell. And here we want to maximize, and we're going to change the variable cells. So highlight all 3s, just click and drag down until you see this, or you could type this in, $B$2, $B$4, and then subject to constraints. So I'm going to add 3. And notice before I add those in, I didn't add the other 3, that x1, x2, x3 are all greater than or equal to 0. That is important. But in Excel Solver, you could just click this box down here, make unconstrained variables non-negative. So that fills in those last three constraints, that x1, x2, and x3 all have to be greater than or equal to 0. So make sure that's clicked. All right, I'm going to click on Add. All right, so add cell reference, value, inequality is less than or equal to, constraint, click on 30,000, add, value, which is the same as cell reference, less than or equal to matches up, constraint is 40,000, click on add, and then value, less than or equal to, constraint is 120, and then click OK. So here, just as a double check, the max profit set up correctly by changing variable cells is correct, and I've got all three constraints set up. At the very bottom, select method for solving. Make sure to click on simplex. We want to do the simplex method. Click on solve, and it gives us a value right here, 1200, 0, 0. Interesting. I'm going to click OK. So I want to write up the answer and then reinterpret that value. So the max profit is right here, $12,000 from producing 1,200, and what did X1 represent? Chandeliers. 1,200 chandeliers. 0. I forgot what the other ones were. I think they were stair railings and latches, X2 and X3. Notice in Excel, those are both 0 over here. So producing 1,200 chandeliers, 0 stair railings, and 0 latches. And that is the answer to this applied linear programming problem.